Hello and welcome to another video in our introduction to Azure Synapse Analytics. My name is Mitchell Pearson and we're now going to take a look at Apache Spark and notebooks. If you like this video, make sure to go to pragmaticworks.com, check out the information in the details below. Take a look at our live training classes, our boot camps, our on-demand learning. We also do hackathons where we teach you on your data and one-on-one virtual mentoring. And if you're buying training from us, that means I get to keep on doing more videos because I'm still employed, which is great. Also, make sure to hit that like and subscribe button, mainly because it makes me feel good when people hit the like button on my video. It's like 11 o'clock right now at night, and I'm doing this video for you, so make sure to hit like and subscribe. In this video, we want to continue what we've been talking about, really just an introduction to Azure Synapse Analytics and understanding all of the key components just a little bit better so we can talk to those and maybe understand if they're meant for us, if they're going to work for something that we're trying to do. Now, I'm going to keep it pretty short here. I had a bunch of slides and I was like, well, do I really want to go down that path? And no, because I am trying to keep all these videos relatively simple. And then once the series is over, that'll leave me some room and opportunity to maybe do a deeper dive into these, or maybe even on one of our Learn with the Nerds events, doing a long session that dives deeper. So in this class or this video, let's take a look at Apache Spark notebooks, and specifically, I want to talk about the Apache Spark cluster. Now, a notebook inside of Synapse Analytics, and you know from our previous conversations, inside of Synapse Analytics, we have the data lake, we have pipelines and data flows, we have Synapse notebooks, we have serverless and dedicated SQL pools. Well, now we're talking about notebooks. Notebooks give us some of the capability that we actually have in other places. And so there's a little bit of overlap for sure, but when you need a notebook, you generally are going to know, I need to be working with notebooks. Notebooks store inside of a notebook, they store your live code. The code that you've written that is designed to do something, whether it's to clean data, transform data, stream data, or even train and kind of test and train your machine learning model. We also can do visualizations. You can actually do some pretty powerful visualizations with tools like Python and specific packages that are available within your notebook. And then we can also do documentation. This is actually one of the things that I think is really awesome about notebooks. As somebody who's done consulting and then I've done training for now 4 or 5 years now, when you would leave a customer and you build them a solution, you always had to build them some form of documentation. And the documentation is always very disconnected from the solution you've built. But within a notebook, you can have the documentation right there. And I love that feature. I think it's super cool. In fact, a lot of my notebook labs that I've built are predicated on the documentation. So the documentation walks you through it. Here's a lab challenge. The answer's at the bottom. You can go through the outline. It's really, really cool. Probably one of my favorite features. Now, in the background, to run a notebook, the compute that it uses, right, to move data, transform data, clean data, train your model, the compute that it uses is known as Apache Spark. Apache Spark is pretty cool. There's a lot you can do with Apache Spark, and so we're going to talk about that here in just a second. But first, what I want to talk about is just kind of some various use cases for working with notebooks. And I just threw a little, like I said, I had a bunch of slides and I said, no, I'm just going to do a quick little list of options here and keep it quick and keep it simple. Primarily, Apache Spark has been known for a long time as a big data processing solution. In the background, Apache Spark, which is the engine behind notebooks, Apache Spark allows you to use distributed in-memory clusters. So Spark is really fast, and it's designed to be able to take that work and distribute it across multiple, essentially computational nodes, multiple worker nodes, right? And so it distributes that work accordingly, and it's scalable. Now, when we say scalable, what we're talking about, in case you're unaware, is when we say scalable, we're saying that as your data volumes grow, you should expect performance to continue to kind of scale with that, continue to do well, right? Because you can just add more worker nodes and distribute that work out. Apache Spark is designed for speed. It's designed to be fast, and so it is very, very common for users and companies and organizations that have a lot of data to use Apache Spark. It can also be used for ETL. Now, ETL is extract, transform, and load, which simply means you connect to your data, wherever that data source may be, you bring it in, you transform it, clean it, apply your business rules, get it curated, ready for the reports, and then you load it into a final destination, right? So that right there is going to be ETL. Notebooks are great at it. And it gives you that extensive, way of kind of expanding the capability of pipelines and data flows. So if you've worked within Synapse Analytics and you've worked with pipelines and data flows, you know that sometimes there's going to be some limitations, right? So we can use notebooks. You can also do streaming. More and more companies want to make real-time business decisions based on what's happening. And so I was working with a consultant, one of the guys that used to work here, and he had built a really awesome solution at like a stadium. And at the stadium, it was a big soccer stadium. And what would happen is at the stadium, as customers would come out on small, breaks or halftime or whatever it is, while people come out, they had sensors and things tied to like the lines at restrooms and concession stands and how many of each item were available at concession stands. And so all of that information was being streamed live to a control center, and they could literally in real time make decisions on where resources were needed, where help was needed, how to start redirecting people to bathrooms that were maybe underutilized. It's awesome, right? Real-time business decisions. And many companies are interested in this, and Spark gives us that capability. We've already mentioned building machine learning models. This seems to be more and more prevalent. People are talking about data science and machine learning all the time. And that's just really cool. I'm going to try not to elaborate on it to make sure this is not an hour-long video, because I love training and I love talking. And then streaming again. So there you go. I told you I put together a real quick list. Apparently I put it in there twice. But there's other things you can do. Spark gives you a lot of capabilities. It really does. What I want to kind of emphasize, and then we're going to jump straight into our demo, which is going to be provisioning an Apache Spark Pool for this video, and then we'll jump into notebooks in the next one. But what I wanted to talk about here is that notebooks themselves do have a pretty steep learning curve. And the reason for that is because they're not a graphical user interface, right? So it's not like if you come from SSIS like I did, where you can drag and drop the components or the task that you want to work with, and then you just configure that component. If you want to connect to a dedicated pool, or you want to connect to a database, you're going to have to actually write all of that code out. You might have to import some packages. You're going to have to choose if you want to use Python or Scala or .NET or R or whatever it is. R is actually not supported today in Azure Synapse Analytics notebooks, but it is in Databricks, which, by the way, also uses Apache Spark in the background. So if you've heard of Databricks, it also uses Apache Spark, just like Synapse Analytics. So anyway, there is a steep learning curve. It's not for everybody. This is definitely a little bit more niche, but it's good for you to understand the fundamentals, and that's why we're going to create a couple of quick videos so you can see a couple of demos. And the cool thing about Synapse Analytics in general is the integration that exists. The fact that you can go in there and quickly build a notebook from your data lake, and it actually creates the connection for you and does quite a bit of the work for you, which is awesome. So we're not going to do that in this video, but what we are going to do is we're now going to jump right over to our demo, and we're going to take a look at how to provision an Apache Spark Pool. So I'll see you there. We can actually create our Apache Spark Pool in one of two different places. I can create it right here inside of Azure Synapse Analytics, inside of my Synapse Analytics workspace, or I could do it back in the Azure portal by kind of going into the admin page or going into the Synapse Analytics blade within the Azure portal. Generally, I create it right here because I'm already inside of this workspace. Now, just like many other things, if I want to create my Apache Spark Pool, I can go down to the Manage Hub, and from the Manage Hub, I can click right there on Apache Spark Pools and then tell it that I want to create a new pool. And I really kind of just walk through the process. Like many things in Azure, it's really relatively simple to do. So I'll click on Spark Pools and then I'll click New. Now the first thing that you want to do in here is give your Spark Pool a name. So I'm just going to call mine something really intelligent like Spark Pool. And then you tell it your node size family. I'm going to go with memory optimized. And then you tell it the node size. Now what the node size does here is this is going to be the amount of compute that's available on each one of your nodes. Because this is a massive parallel processing architecture, you essentially are going to have a kind of a control node or a master node, and that sends the work down to the worker node. So you have a control node and then you have a number of worker nodes. So if I have 3 nodes right here, I would expect that I have 1 master node and then I have 2 workers, right? But I also have something really cool turned on by default, which is called auto scale. And auto scale is a capability that's there that is designed to give you flexibility and versatility so that as your data volumes grow or as different things are performed, different actions are performed, it can scale up and scale down to give you both better performance but also help you to reduce your cost, making it easier to provision how much compute you need, because sometimes that's hard. So you can do that. You'll notice that my estimated price is going to be $3 to about $11 per hour. And then there's something called dynamically allocate executors. And so executors are, without going into the architecture of Spark, you have executors on each one of your nodes. And this will allow you to come in here, enable it, and set a default number. All right, and if I remember correctly, there's actually a spot in here. It's been about a month since I've actually provisioned one of these or taught a class on Spark specifically. But I think maybe in the settings as we go through this, there's a configuration file that we can upload and we can set. I know for a fact you can do it. I don't know if it's here, but I know you can go into the management of your Spark Pool later and you can upload it. And you can also, there are commands within a notebook that will allow you to change certain properties and settings as well, which that's for those of you that maybe come from Databricks or you've worked with this on-prem with Jupyter Notebooks or whatever. That capability does exist as well. But this is cool. This is one of those newer features that lets you have a little bit more control if you really understand your workload. I will say that I generally, for training purposes, will go with a small 4 virtual cores. If you go with 8, there's a good chance, especially if you're on a trial edition, just chugging along here, learning Azure with us, there's a good chance you might run into some kind of soft limit, meaning Microsoft actually won't let that work once you go to run your notebooks, and you'll have to put in like a quota request with Microsoft. So if you see something like, hey, you have 32 cores and it only lets you do 16, that's because 8 virtual cores times 3 worker nodes is going to be 24, and that's what it's referring to. And I've seen that error message when I've been teaching this class. I actually had this happen this week. We got to the part on notebooks and somebody had that error and I was like, oh yeah, that's why I always do small, so you don't have to worry about that. Obviously in a real production environment, you would submit the quota request, which simply says, hey Microsoft, I know what I'm doing, let me out, right? Open the gate, I know what I'm doing, let me do my thing. All right, so that's enabled. I'm gonna leave it disabled. We are not quite diving that deep. And then we'll go into our additional settings. There's a lot of settings here, and like most things with Microsoft, this can be pretty intimidating. It looks like 3.2 version of Apache Spark is now generally available. Last time I was in here, it was actually in preview. So number of minutes idle, it'll automatically pause after 15 minutes of being idle. That is great. This is actually different than my experience back when I worked with Databricks. So I haven't worked with Databricks in quite a while because I've been working with Microsoft technologies and what Microsoft pushes, and inside of Synapse it's this. But in Databricks, you actually used to have Spark clusters that you would develop or provision, and they would stay running unless you went and turned them off. Here, these are kind of like serverless pools, because what happens is when you run a notebook, it spins up a session that is set up and created from this configuration here. And that session is started when you're running your notebook, and then it's automatically paused. So this is, again, a fail-safe to make sure that you don't come to work on Monday and have a $12,000, $15,000, some crazy bill because you went with a large Spark pool and then you forgot to turn it off. This will actually turn it off for you. So this is an awesome feature. I would recommend not disabling it until you really know what you're doing, or if you need it to run, whatever. So Apache Spark, I would generally go with whatever the latest version is. The latest version is going to give you all the best features. However, for backward compatibility reasons, you can go all the way back to 2.4. If I go back to 2.4, you'll see things like Delta Lake is going to go back to 0.6 from 1.2, meaning I don't get all the features of Delta Lake. And you're going to see other things change here, like I think Scala goes back to 2.11, Python goes back to 3.8 or 3.6. And so 3.6, 2.11, 0.6. So even .NET went back quite a bit. So the point is, go with the latest version, unless you're trying to do something for backward compatibility and maybe you're watching a demo or you've gotten some stuff from the web and whatever package you're using or whatever you're trying to do just isn't working quite right in the latest version, then maybe go back to 2.4 and see if it's a backward compatibility issue. And I have ran into that with Databricks on notebooks where I've provisioned specifically in my online class for Databricks, where we have a demo, that stopped working because students were obviously creating their Spark clusters on newer versions of options that are available in Databricks. And when they would import the package that I was doing in the demo, it actually didn't work because those packages had not been upgraded. A lot of packages are created by the community for the community, so they're not necessarily maintained right away. And so it was failing. So what's the solution? Well, we're going to go back to an older version because it's supported there and it works. All right, so a little bit about that. And here's the Spark configuration I was talking about. This is where you can do a configuration file that lets you change a lot of the properties on your Spark cluster. This is really cool because you can create those configuration files and you can use it across your Spark clusters, making sure that they're set up the way you want them. And this is actually something that I show how to do and I teach when we're teaching our Azure Synapse, specifically when we're getting into Apache Spark and notebooks class. You can also turn on something known as session level packages. Now, what session level packages means, and this is a lot if you're brand new, but again, there's a steep learning curve to notebooks and Apache Spark. And there's a steep learning curve because what happens here is you're doing everything in code. And in order to make the PySpark that you're working with or the Scala and R back in Databricks easier to work with, a lot of people in the community have built packages. And there are some awesome packages out there. And the packages are really, let's think of an easy way to explain them. They are very specifically designed for very specific purposes. For example, a very common package is called NumPy. And NumPy is numerical Python. What it means is if you're working with numerical data, you can use NumPy to perform actions on your numerical data, and it's way easier to perform those actions with numerical Python than it might have been with just using the basic PySpark and you having to write a bunch of code to do the same thing. So these people in the community have written these packages that are all of that code, but that code is encapsulated in just a basic kind of function, right? That you call the function and you call what you want to do and it runs all that code in the background. You have no idea what it's doing and that's okay. It's awesome. The problem is that there are thousands of packages and they take a lot of time to learn and understand, and there's some very close correlation with just regular PySpark, so that gets confusing. So anyway, if you know what packages are, good. What this does is it allows you, when you're working in an individual notebook in a very specific session, you can actually add your own package and you can test it, build a proof of concept. Then if it works, you can reach out to the administrator and say, hey, this package is awesome, add it to the Spark pool so that everybody working with notebooks will have access to that package. So that's what it does. Down here we have something known as intelligent cache size. This is another one of those newer features that's available. The idea behind this is that as you're working within your notebook and you're going through all of these different code cells, this can actually take data and information and store it into memory so that it is available later on. And if I remember correctly, this intelligent cache size is actually allocated on each of your separate worker nodes, which, remember, a moment ago on the previous slide, let me just show it again. On the previous slide here, when we specified our worker nodes, we also specified, messed up there, we also specified how much memory and how much CPU we wanted on each of those nodes, right? If I turn on intelligent cache, you might want to go up to a bigger node so that you have more memory on each of those nodes, because now some of that memory is going to be allocated just for storing data. Obviously, that intelligent cache is going to make performance in some situations quite a bit better, right? And so that's the idea behind it. Microsoft has some great documentation on it. I know because that's, when it came out, that's how I learned about it. In fact, Microsoft does a great job with all their documentation around Azure, Power BI. They've done a really, really good job. And so that's what intelligent cache is. I think the recommendation by Microsoft is generally start off with about 50% and then, make adjustments based on that, based on, running your notebooks, looking at the execution plans and understanding that a little bit better. We are almost done. So the next thing here is tags. Tags are awesome. In fact, I would highly recommend, there are ways that you can go in and essentially enforce tags. You can make it so that every resource you create in Azure has to have a tag on it, and you specify what those tags are. So what tags are, and I'm not quite sure if I've mentioned this so far in this series, but what a tag does is it's there for billing purposes, right? So in our organization, let's say somebody leaves a database on, they leave a dedicated pool on, a Spark pool, whatever. What we can do is we can go look at it and we can look at the tag and say, oh, the owner of this resource is Mitchell. So then they can text me, email me, call me, whatever, and say, hey, did you mean to leave this on? No, I did not. Please turn it off. Thank you. And they know to turn it off. Or we get to the point where we just have too many resources. We need to start deleting them. But we're like, who created the database? Who did this? We don't know. It's been sitting around for a couple of years. If you put tags on it, you know who it was. And then you know if it's relevant or not. So a lot of times I do tags that are really kind of a couple of tags. I'll do owner, right? So I'll come in here and do something like owner. Then I might add another tag that has purpose, right? And I'll put in here the owner's Mitchell Pearson and the purpose is ASA YouTube series, right? And that's the way that we'll know, hey, that's for Mitchell's YouTube series. We should keep it. It's very important, very important. All right, so I'm gonna get rid of the tags because I'm not actually gonna, but it's just a key value pair. But when you're looking at your Azure subscription, your billing, your cost management, those tags will help you to filter down your reports. You can see how much you've spent on certain projects, how much have been spent by certain marketing departments, whatever it might be. Tags are incredibly helpful. I highly recommend them. But what I'm going to do next is go to Next, Review and Create, verify that everything here is working exactly like I would expect. We're going to be putting 4 virtual cores and 32 gigabytes of RAM on each of my nodes. That's going to include my worker nodes as well as the control node. I forget because there's a couple different MPP architectures, dedicated pools, Spark pools, so on and so forth. I forget the exact terminology for each one, and I use the terminology interchangeably. So if you go and you're like, Mitchell, the master node or the control node that's actually this other, I apologize, but the concept is the same. Your queries are going to go to like the master control node, and it takes that work and it distributes it across the different distribution nodes, and it's kind of responsible for making sure that all of the worker nodes are doing their job, and if one breaks down, it removes the work and moves it somewhere else. That process and that idea remains the same. Now, I'm going to smash that create button right there, just like you did with the subscribe button earlier, and I got a failure. And I think the failure, and I'm going to have to get this fixed because I noticed it a moment ago, is a problem with my subscription. But I'm going to look at it and we're going to see. Let's see if we can view details here. And it is a problem. My subscription got disabled. So I'm going to fix that. I'm going to leave it here. It is what it is. I'm going to make sure I get that fixed for our next notebook or our next video when we do notebooks. So thank you again for watching this video. Thank you for following us on this series, and I'll see you in the next video.